One of the very first questions you might ask yourself is, what is forensic science? Well, there's a textbook definition of forensic science, and that is it's the application of science to the law. Well, what exactly does that mean? And what are we doing? Well, we begin by going to a crime scene, collecting evidence, and then submitting that evidence to a forensic laboratory for scientific testing. After that, we'll write a written report to summarize our findings, and then those findings will be presented in the court of law. So today I'm going to talk to you about these two main aspects of forensic science, the first being crime scene investigation, and the second being the laboratory analysis of evidence. It is very important that we take a scientific approach to investigating the crime scene. We'll begin by making sure that the crime scene is secure. We will take notes, make sketches, take lots of photographs. After that, we'll start to search for evidence, and then upon finding evidence, we will document its location, we will collect it and package it into an appropriate package, and then it will get sent to the forensic laboratory for testing. It's important to make sure that the appropriate test is requested for each and every item of evidence. Once evidence is received in the laboratory, there are different categories of analysis that can be performed. One of those is forensic biology, another is forensic chemistry, and then physical evidence is all of the other types of evidence that is not considered either biology or chemistry. Some examples of these are latent prints. So here we will learn about how to detect unseen or latent fingerprints, how we collect those fingerprint impressions, and then also some comparison techniques. Another category of forensic evidence includes firearms and tool marks. So this could include having a bullet and attempting to determine which weapon it came from. Or perhaps an individual attempted to obliterate a serial number. So there are steps that can be taken to attempt to restore that serial number. And we will also engage in some crime scene reconstruction activities. As far as paint chips go, one of the most common types of evidence that we can encounter is paint from an automobile accident. These paint chips are lost during the impact of the accident, and they can be found on the ground, another vehicle, or perhaps even an individual. With our paint chip analysis, we look at the different layers of paint under a microscope, and we can perform microchemical tests to see how those different layers of paint react with different chemicals. We can also put two paint chips side by side under the microscope to compare the layers of paint to see if they are consistent with one another and potentially whether or not they originated from the same source. Hairs and fibers are another interesting type of evidence that we will encounter not only in our coursework, but also in real crimes. For both of these, we are comparing different hairs to one another to see if they potentially originated from the same source. We do this microscopically and look for different characteristics of the hairs. As far as fibers go, we use different microscopic techniques and different applications of light to see whether or not these two fibers are consistent with one another. And again, could they have originated from the same source? Bloodstain pattern analysis is also a very important discipline in forensic science. In our coursework, we will look to attempt to determine the force and angle of impact, and we will also do some crime scene reconstruction based upon the bloodstain patterns that are present. Forensic biology includes serology and DNA. Serology is the detection and identification of body fluids. So this could be something like blood, semen, urine, saliva, feces, any kind of body fluid that we could potentially encounter. And then the other part of forensic biology is looking at developing a DNA profile that is unique to each and every individual. Lastly is forensic chemistry and toxicology. Essentially, we are attempting to look for a variety of different kinds of chemicals, whether they be drugs, explosives, accelerants, or dyes, and attempt to identify them to what they truly are and potentially their source. As far as toxicology goes, we will be attempting to remove or retrieve these drugs or other kinds of poisons or chemicals that are existing in biological fluids, typically blood and urine.